How do you see yourself competing with the Bosch, Shimano?
How does 150 Newton meters fit into that? Let me explain that.
Yeah, right.
So
what's your perspective on that?
below that, people actually won't know how to ride their bike hard enough to actually feel it.
Totally.
In a way, an e-bike motor could save analog bikes in my mind. My background was at Tesla, and I would just spend my evenings and weekends like staring at my bike, like where can I put a motor on this thing?
Are you working on anything else in the bike market?
So the torque density is insane. It's just off the charts.
That's very exciting. That is big torque numbers.
Time and time again, people at Sea Otter would come up to us and say, "Hey, I've got a friend who's in a wheelchair," and I was like, "Okay, let's build a prototype." So.
Okay, welcome everyone. We are back with the RECON MTB podcast. Today I have a special guest, Toby Ricco of Bimotal.
Awesome, Nick. It's great to be here. Thanks for having me.
Yeah, of course. You know, there's been a lot of buzz lately. You have a very cool product that you're working on. We've seen quite a bit of media recently, Berm Peak, maybe RECON MTB with a video soon. And today I just wanted to talk to you, go through, your backstory, the product, and what brought you to here.
Awesome. Excited to chat.
Cool. So let's get started. I heard a rumor that you were from here, Los Gatos, California.
Yes. If we want to get super detailed, I originally was born in Albuquerque, New Mexico, but moved when I was about 7 years old. So I grew up in Los Gatos and got into mountain biking when I was about 12 and was pretty close to Belgatos Park, which you guys are familiar with.
Oh, yeah.
Some good little trails there. It's small, but some really fun stuff.
Yeah. And, were you always into engineering and building products? Were you, I assume you went to Los Gatos High then?
Actually went to Lee High School. And I was really kind of born a tinkerer. I can't remember how early it started. I mean, I think 2 or 3 years old, I got like a building block set. And I have a feeling it started that young. I think by 6, I was using power tools. And then by like middle school age, I just was in the garage. Like the normal kids were playing video games, and I was just building stuff.
And did that materialize as you building bespoke products, like as an inventor kid, or were you just working on bikes? And how did that come together?
Yeah, so that really took off. I got one of those Sharper Image Razor electric scooters, and those go maybe like 10 miles an hour. So I had it for about a week, and I decided it was just way too slow. And so this was probably around 2004, something like that. Like eBay was becoming a thing, the internet was becoming a thing, and so I went online. I was like, okay, let me look at motors. So I was looking for larger motors, and then let me look at batteries. And so then I had a lawn mowing business, made a little bit of money, and then started buying parts to soup up this scooter. And so that's kind of how that hobby started. And so I did, I want to say like 8 to 10 electric scooter builds throughout high school. So I was really into the go-peds and just electrifying them and seeing how much power I could put in a really small stand-up scooter. And then that slowly transitioned into electric go-karts.
Okay. Yeah, so all very translatable technology to what you're building today. So you're always an inventor, always a tinkerer. And fast forward to today, you've built a really cool company with Bimotal, which is, maybe you can walk me through exactly what it is.
Yeah, so Bimotal is really an electric powertrain technology company. So I'm not looking at it as like an aftermarket conversion kit company or not necessarily a bike company. We're trying to make the kind of the highest torque density, power density electric motors for almost any application. So we're starting in the bike market because I had a knee injury and a personal need and a passion for mountain biking. But long term, we're trying to make the best motors for small applications, bar none.
Okay. And your entry into that business was with the Elevate. Yep. It is an add-on system to any normal pedal bike that you can basically turn it into an e-bike. So walk me through how you came up with that idea. Was it because you didn't want an e-bike, but you wanted e-power, or you saw a market opening for people who had normal bikes, but not the money to buy e-bikes? Kind of bring me to where you decided to go after this specific product.
Yeah, it's actually a very specific story. So I think it was like 2018, 2019. I was skiing and crossed my skis. Binding didn't come undone, and I tore some cartilage in my left knee. That was a bummer, and also love to mountain bike. And so with that knee injury, I found that I could do like low grade hills, but as soon as it got beyond a certain grade, I'd get pretty bad knee pain if I pushed too hard. And so I really liked my bike at the time. I had this 2016 Cannondale Jekyll lefty with a dyad like switch rear suspension. You could choose, I think it was like 85 millimeters or 160 of travel. The lefty was super tuned in and stiff, and it was maybe like a 29 or 30 pound enduro bike with 160 mils of travel. So I loved that bike and had it all spec'd out how I wanted. And I was like, man, I really don't want to get rid of this and get an e-bike. So I would say and
at the time, the e-bikes were not very impressive.
Correct. Yeah, there was no TQ. We were a couple generations back on the Bosch, and things were much heavier and pretty clunky, pretty expensive.
Oh, yeah. I remember.
Yeah. Yeah, so I spent a lot of time doing background research before I was like, okay, I'm just going to build it. I wanted to see, like, is there anything else out there? And I think there was the Bafang mid-drive kit that existed. I'm not sure if CYC existed at the time. There was
various hub motors, right?
Various hub motors, the Copenhagen wheel, which was super heavy, Ruby, which is like a friction drive that rubs on your tire. Mm-hmm. And none of these would work. And I'll maybe quickly talk you through why. I decided none would work. So if we look at the Copenhagen wheel, it's that huge red disc, and I don't know how many kilograms, but I think it was 8 kilograms or something. Just
too much for a rear wheel.
Would not work on a mountain bike. Yeah. No way. And then next we'll talk about friction drives. So those have a little roller that kind of rub on your tire, and that's great for super low torque, maybe like city little boost on flat or slight grade, but no
on
way.
A kind of slick tire even too. Tire. So imagine mud and grit, and it just doesn't work.
So no way that'll work on a mountain bike and actually put down real torque. And then probably the best contender was the bottom bracket aftermarket solution. So the Bafang. I think at the time you had to drill holes in your frame, and you have this motor that's still pretty big diameter right on your bottom bracket, which is not really where you want to put something, because that's where the rocks go. And so it's kind of this process of elimination, like, okay, none of these work. And so, at the time I was working at Tesla in Palo Alto, and I would just spend my evenings and weekends like staring at my bike, like, where can I put a motor on this thing? And so it was 2 months of that. Like, I literally just stare at my bike for an hour, like just sit down on the garage floor, look at the bike, and be like, where could I drive torque? And then finally it was like, the disc brake takes a lot of torque. I wonder if I could make something that drives off of that. So that's really how Elevate was born, and it's been a long time getting into production, but super excited to have it shipping now.
Awesome. So all that reflection brought you to a point where you decided to build the Elevate. Now, walk me through that process. You have some parts here you can show us.
Yeah. So we'll start really early. This was literally the first flavor of Elevate. Before this, it was a printed piece of paper and cardboard cutout. So started very simply. This literally just has the same bolt spacing as a post-mount brake caliper. This is a high torque outboard motor from, actually, I think that was from an electric skateboard, but they also make similar motors for RC airplanes. That one is called an outrunner, where the outside of the motor shell is actually the rotor. And the reason they do that is you can get more torque from a smaller motor. So you're basically moving the air gap, the gap between the motor windings and the magnets further out. And so you get more torque per size, but it's much more difficult to seal, contain, and make it quiet. So that's deeper into the optimization, but we'll zoom back out into the early days. So
oh boy, that looks like a torture device.
Yeah, so the chainsaw, or whatever we want to call this, the saw blade, this was maybe not the safest version of Elevate, and it had some problems. So this was pretty early Elevate now, and so we still have that outrunner motor. You can kind of see as I spin.
Yeah, the gear turns.
The gear turns. This was our motor controller, just hot glued or epoxied on there. But there is a gearbox in here already. So this was probably version 5 or 6, as rough as it still looks. So these gears, basically, this is how this setup worked, and this actually ran pretty well. Like, I was running this in the field, but it had a couple big challenges. So one was the gear teeth would start to squeak because it was metal on metal.
Yeah.
Dry running, and you get a little dust in there, and then you just get this horrendous squeak. So I found this like really viscous graphite grease, and I would paint the gear teeth in this graphite grease.
Well, you don't want grease too close to your brake pads, do you?
And this is also your braking surface. Yeah. So there's your fatal flaw number whatever 2, if we consider the safety as number 1. So this just wasn't going to work, and this was how Elevate was for maybe a year in early prototypes and figuring out motor controls and a bunch of other stuff. It was at maybe 2:30 or 3 a.m. when I had the idea that, hey, there's a brake caliper on the bike, and the brake caliper has width. And it is something that is so simple when you see it, you're like, oh, that would be easy to think of. And it's like, no, actually that jump took a long time. So brake calipers have width. And so you're basically guaranteed clearance to your spokes. And so the idea was, okay, what if I run a gear underneath where the caliper goes, and use that clearance that I know is there to the spokes to fit a wide gear. And a wide gear is important because that lets me go to a polymer. So the smaller gear teeth have to be hardened steel. A wide gear lets me run like an engineered polymer against it. And you need that to be able to run a gear mesh dry. So that was a really big jump, but it lets you, 1, have a much safer design, and then 2, you don't need to grease it. Like the polymer has self-contained lubrication. And
I imagine, too, it sort of detaches the heat of the braking surface, which is significant, and the actual motor drive. So
exactly.
That becomes, not a problem anymore.
Yeah.
Great. And so what version is today's version, the at-market version of Bimotal Elevate?
Yeah, I mean, it depends how you count versions. Probably around the 10th or 11th full mechanical redesign. If you count revisions and permutations, we're probably in the hundreds or thousands.
Right.
If we're into software simulations, we're into the tens of millions of iterations in terms of motor design. But yeah, probably about the 11th or 12th full mechanical redesign.
Cool. That's awesome. I mean, let's step back for a second because it's important that people understand this is an e-bike motor you can bolt onto pretty much any pedal bike. So it's a very unique product market fit that not a lot of people consider when they're shopping for an e-bike and could potentially get more people in e-bikes. So this is, a system, costs a couple $1,000, much less than a complete e-bike, obviously, or e-bike frame. And you can attach this to your rear brake rotor, have sort of like the light e-bike style power, but at a throttle actuator.
Yeah, so you covered a lot of things there, and let me try to zoom in on it. So the motor is actually closer to a full power bike. We're able to do 750 watts, yet have it be about the weight as like an SL bike setup, or actually lighter. The torque is somewhere between like an SL TQ and a full power. So we're doing about 50 Newton meters continuous, 70 Newton meters peak.
Okay.
And so that's kind of the power. And then the other part you touched on was the throttle actuation. So yeah, to date it is actuated by throttle. We are working on pedal assist. So every system we sell today is future compatible with pedal assist. We already have the Bluetooth chip. Let's see if I can open this up here while I talk. So we already have the Bluetooth chip on the board. So that's this little chip right here, and that'll talk with a wireless power meter. And so yeah, just that's something we get asked a lot. Like, why haven't you guys done pedal assist? The answer is we're working on it, and it's actually a much harder problem than you might imagine. So we've been talking with, we've talked to 4i and a lot of the power meter companies, and we actually have to basically reinvent power meter technology to sample 10 times faster than any power meter ever made.
And do you see people wanting pedal assist? Me, I like the easy way. I love throttles. I love dirt bikes. I wouldn't even want pedal assist.
Yeah, so it's probably 50-50. We have some people who absolutely love the throttle, and it's important to note that you can actually use the throttle like pedal assist, and that's kind of how I ride. I'll shift into a hard gear where I have some resistance, and then I'll apply throttle to the point where basically I feel like a comfortable level of exertion. So I create my own pedal assist, and it's very easy to do with modulating the throttle. But having the throttle is super nice. I was riding in Tamarancho yesterday, and there's kind of this flow trail, and being able to use the throttle to speed up to a berm and get some air is just like the coolest thing in downhill riding I've ever done. So I would say both, and our dream is to offer pure pedal assist for class 1 so people can be fully compliant, and that'll be the main product. But then we'll offer a combination where you can get pedal assist plus the throttle.
Great. And there's one thing to attach a motor to the back of the bike, but it's another thing for the battery. So walk me through that process, and do most bikes have space for this battery?
Yeah, so the battery right now is a very small, compact cube. Here we have the next version we're coming out with, and it's this shape instead of a bottle. This is something very important because we get asked a lot. We could do a bottle, and we may eventually do a bottle, but we'll only get about 200 watt hours. This we have 300 watt hours, which is a pretty big difference if it's your primary battery. And the bottle is actually less compatible with suspension layouts compared to this design. So this is shorter, and so if you can picture kind of a triangle of most bikes where the shock is, this fits the vast majority of full suspension bikes. We have run into some downhill bikes where this does not fit because the frame's a lot kind of narrower. And we've worked with some of those customers to either do a custom battery mount solution or just find some way for them to work with the setup. But this battery choice, as simple as this shape is, actually was very intentional. Like even this little angle here is for clearing shocks that we had to battle for millimeters in the layout internally to make that work.
And how much does that weigh?
This is right around 1.5 kilos.
Okay, so roughly
3.5
pounds. Okay, yeah. Awesome.
So the motor is almost exactly the same.
So overall, it's a very light system. Now, the battery only being 300 watt hours and being small, are they meant to be interchanged during a ride, or what's the range like?
Yeah, great question. So one of the things that I actually like about this is basically the idea that you're only going to carry as much of an e-system with you as you want. So you have a full power motor, and if you want to do an hour and a half lunch ride, one of these packs is perfect. If you want to do 3 hours or 4 hours of trail riding, bring two packs. And so it's very modular. You can kind of carry how much energy you want with you, keep your bike light, and there's also a lot of situations where you maybe have a trail that's set up to be lapped. And so you can either stash these at your car or trailhead, and you can lap with this lighter bike and then swap out the pack. So I really like the fact that it's modular. You get to really choose your own adventure in terms of battery energy.
Awesome. Totally makes sense. And I noticed this is detachable on a quick release.
Yep.
So walk me through why someone would want to do that. Is that a normal thing they would do, or is it just for ease of installation?
Yeah, so I mean, it started with the original motivation for the product was I had this bike I loved, had the knee injury. I was planning on recovering. I didn't want to be injured forever. I was like, I'm going to get strong again, etc. So I was like, I'll be able to take the motor off when I don't need it, or if it's an easier climb. So that's how it started. I was probably more into XC riding at that time, more into like hill climbing and less about descending. In terms of my personal riding style. But I think the whole bike, like especially the mountain bike market, has evolved a little bit where bikes are longer travel, more people are thinking about downhill, and there's a lot of excitement around enduro and going down the hill. And so one of the things people will ask us, like, oh, okay, this is kind of a chunk of unsprung mass, right? If this is on your rear wheel, will that affect suspension performance? And the answer is yes. You can feel it if you're very in tune with your bike. We have pretty wide range of customers. We have some customers who are newer, more intro riders, and then we have some customers who are like 95th percentile, 99th percentile. I would say probably 80 or 90 percentile in terms of skill level will actually notice this.
Right.
Below that, people actually won't know how to ride their bike hard enough to actually feel it.
Totally.
So what the kind of circling back to your initial question about the quick release, originally it was to have two bikes in one, pedal bike and an e-bike. If we're looking at the application on a downhill bike or an enduro rig, it's also nice to be able to pop the motor off and put it in a hip pack if you're going to go down some really gnarly, chunky descent. So you actually don't notice it on jumps. You don't notice it on flow trails. It's really if you have kind of like going down stairs. If you have a bunch of sharp edges where the motor's suspending up and down a lot, that's where you'll feel it. The other situations you won't. So for those trails, we recommend you pop the motor off. And
the rider would just put that in their hip pack or backpack?
Yep.
Okay. And the battery is pretty much designed to stay on, although they could quick release it too.
Yeah, the battery has super simple like Velcro strap just to tie it in, and it's pretty low and centered on almost every bike, right? It's where your bottle cage is, and so I actually find my bike handles better with the battery there.
Yeah, I actually think that a bike with the weight right there, around like 38 to 40 pounds, rides like the best. It's awesome. Yeah. So I would just leave that on, but I agree. I would remove it, find somewhere to stash it, and then all of a sudden you have like this really cool pedal bike.
Yeah, yeah, and that's also kind of what's exciting is you can have if you have a reasonably light enduro bike, you can have a sub 40 pound electric enduro bike, and you take the motor off on your descent, and you have this bike that is kind of nimble and flickable again. Like it's really like your pedal bike. Okay, great. So now that we understand the product, tell me about where you see this market. Do you see the market for an e-bike conversion kit like this to be very big, bigger than normal e-bikes, or is it somewhere between? Yeah, that's a great question. I obviously recognize it's pretty niche to start right now, but I actually think it may get much closer to fully integrated e-bike market size than people think. Do you see that as more of an education game? Because right now, most consumers think I have a normal bike and I have a $5,000 e-bike, and there's no viable in-between. And this product at this point to me is one of the only viable in-betweens, and I imagine it will only get better. Exactly. Yeah, I think it's going to be a combination of things. So a lot of people don't believe it's real until they ride it. And exactly. They ride it and they're blown away by the power and torque. And the amount of engineering that's gone into that is kind of insane. So I think just getting more units in the field is going to be, our first step. And so we have a pretty big order backlog, and we're ramping production, and that'll really help kind of nudge the perception that this is a real product. It's shipping. It's the real deal. Oh yeah. Some of the best marketing is seeing it on the trail, someone else who's purchased it and has something good to say about it. Yeah. Yeah. So I think that's going to help. But the way I'm fundamentally thinking about this is different than an integrated e-bike motor. It's really like your bike is now a component. And so if we look at the mountain bike market specifically, people love to upgrade their bike. Mm-hmm. They like to put, for example, I love Hope brakes. I put the first thing I do, any bike I get, I put Hope brakes on them. And people like to upgrade their suspension and all these things they like to upgrade. And so having a modular motor architecture where, we're going to have a better drive inverter in about 6 months. And so this motor is going to get better. The battery is going to get better pretty quickly. Like there's solid state batteries on the horizon. New cell chemistry comes out. We can put that in our pack, and a rider, instead of like being out $8 or $10 grand, a new battery is under $400 with this modular ecosystem. The motor is going to be $1,250 on its own. And so the thing that I think is super exciting is you have this kind of rate of change in technology with the motor systems, and you see it with Bosch, DJI, like everyone's coming out with new motor systems. kind of asynchronously, the poor bike companies are trying to catch up. The poor consumers, like, what do I buy? Like, my expensive e-bike's out of date. And so I think this is going to disrupt that, where you can have a really good bike frame setup that you love, and your e-powertrain gets better with time, and you're not out a full system. It's more like, hey, I'm upgrading a fork or something like that. So it's a totally different shift in how we see e-powertrains.
Very cool. Do you see this system getting more integrated than it already is?
It will definitely get more elegant, especially the battery. That is something we've gotten feedback on, and I'm well aware it's just been an issue of triage and priorities. So we're working on a cleaner version of the battery that's going to have kind of a side load quick connect and much more industrial design done with it. So that'll get sleeker. And then, we're at 300 watt hours right now. Eventually that'll go up to 380 for the same size and weight. And then probably next gen cell technology will get higher than that. So it's just going to get significantly better. And so that's kind of the way I'm thinking about this tech too, is right now it's like, if you ride my bike, you'll be pretty happy. Like, oh, this is pretty good and can almost compete with like a Turbo Levo or something like that. As the motor and battery tech gets better, that gap is going to close, and we're going to be able to close it faster because we can iterate really quickly.
Exactly. And the beauty of this industry for the e-bike side is you're riding, the innovation that exists and the billions of dollars that are being poured into the EV market and eVTOL, airplanes, all of that. And then we sort of get to benefit from that. We get the better cell technology. We're definitely on a lag. There's like a 3-year lag from what goes into Teslas as to what we can get in the e-bikes. Yeah. But it makes us know sort of where everything's going. So it's advancing very quickly, and it's very exciting. So walk me through the greater business vision. You had mentioned something key, which is you're just going after electric mobility.
Yeah.
Walk me through how the other parts of that large market factor into this business you're building right now with the Bimotal Elevate.
Yeah. And here maybe I'll grab a couple props again.
So you brought a few props here. Maybe walk me through the other products that maybe you're developing or you could show us today.
Yeah, awesome. So this motor right here is called Activate, and this has a lot of similar parts as Elevate. You can kind of see the motor size here is similar. The internals actually share a lot of the same gears. And this is a motor we've prototyped for wheelchairs.
Okay, so not even for a bike.
Not even for a bike. No, this is dedicated for wheelchairs. And right now we're again resource constrained as a company, so we have to focus on production ramp of Elevate. But once that is stable, we'll be able to dedicate more resources to this. The reason we built this was we had time and time again, people at Sea Otter would come up to us and say, hey, I've got a friend who's in a wheelchair, buddy, whatever, someone they knew was in a wheelchair, and they asked about this motor. They said, would this work on a wheelchair? Because the wheelchairs on the market today that are electric are super heavy. They're just unwieldy. And so that happened tens of times. And I was like, okay, let's build a prototype. So this was done last summer as a hackathon with a bunch of our interns. So we all got together and did like a 12-hour hackathon, did a bunch of CAD, and then kicked off prototype parts. So this actually, we have one set of running motors in our shop in Berkeley for the wheelchair product. So we're excited to eventually bring that to market with once we have the right resources to do that.
Very cool. And do you see that as being potentially a bigger market than the bike side, or?
Similar size. Unfortunately, the market is growing. We have aging population, more and more health issues. It's one that is maybe more in need of disruption. The motors that wheelchairs are using today, a lot of those are still like kind of the same tech that was used in the 80s. Like,
oh, wow.
The high level thing. So you mentioned weight. I think the state of the art wheelchair powertrain is about 40 pounds right now.
Oh my goodness.
And 2 motors in our battery would be sub 10.
Yeah.
So it's a factor of 4, and if
it's
huge.
The same motor as the Elevate, it's overkill, no? For power and...
For power, yes. Torque, no.
Okay.
So you need a lot of torque for a wheelchair because you have maybe higher weights and they have to be able to go up a ramp. And so it turns out you actually have almost identical motor requirements because torque is what drives motor size. And so that what we're excited about is we can kind of leverage everything we're doing in the bike space, use the same motor, use the same gears, and that'll let us have a more economical solution on the wheelchair side.
Okay. Are you working on anything else in the bike market?
Yeah, so we do have on the table here this mid-drive.
Very exciting.
Accelerate. This was a project we have been doing kind of engineering development on under a contract. This is basically aimed to be a very compact drive unit, kind of, again, specialized SL size, or now similar size to the DJI drive unit. But we're able to do 150 Newton meters from this. We've actually tested it up to 180 Newton meters.
Wow.
So the torque density is insane. It's just off the charts.
What allows you to reach those torque figures?
We have a patented gearbox layout here. So there's just a different way we're combining and arranging gears to basically get rid of the third bump that you see in the Shimano and the Bosch. So we've figured out a way to get rid of that and still kind of decouple the motor diameter from where the spindle is. So we've solved a couple problems there. That's in a pretty detailed patent of ours that lets us get that torque density. And so we think this will be pretty disruptive when it comes out.
That's very exciting. That is big torque numbers. Like we were speculating in one of our past podcasts that e-bikes might have reached torque or peak power, peak e-bike, peak, maybe we can't out of that size motor reach any more power, but obviously not. What's your perspective on that?
Yeah, so that's a great question. Like what's too much? Where do we want to go with that? So my background was at Tesla, and if you see what they did with ludicrous mode and all those high performance cars, I got to test really early versions of ludicrous, and you're kind of blown away. And people generally love performance,
right?
And so I have a similar philosophy when it applies to bikes. There are practical limits, like there's the 750 watt limit in terms of power. And then there's practical limits of chains and cassettes and derailleurs. There's being respectful and polite on a trail. How does 150 Newton meters fit into that? Let me explain that.
Yeah, right.
So it turns out on e-bikes, people are riding at much lower cadences than you would expect. Like 50 is very typical cadence on an e-bike.
And that's where you see the requirement for higher torque.
Yes. Yeah. And so everyone's like, oh no, I ride at 80 or 100 RPM, which is like a good performance kind of athlete cadence, but most people are not riding there. And so on e-bike, the cutoff is around 40 or 50 RPM. In that range, 150 Newton meters equals 750 watts because you multiply the cadence by the torque to get the wattage.
Okay.
And so that's kind of where that number comes from.
So it allows the rider to pedal at a lower cadence and still have the bike have that output of 750 in.
Exactly.
Okay.
Exactly. And so the product is aptly named Accelerate because that's really what it lets you do. It really lets you kind of accelerate out of a corner. And if you're a strong rider, many e-bike motors, you feel like you can saturate, right? You'll pedal, you'll be getting assist, and you have this assist curve that's like kind of linear, and then it's flat. And so you're like accelerating, you feel like you go off the cliff because all of a sudden the motor can't keep scaling its torque. With 150, it feels different. It just feels like even if you're a strong rider, the motor will match you no matter what. And that even at that 750 watt limit, it's something about having that higher torque and really fast pedal assist sensing just makes it feel bionic.
Now, explain to me the 750 limit.
Yeah, so 750 watts is basically an e-bike regulation that is pretty new in EU. I think it used to be 1,000 watts with 250 watts continuous. The way they define that 250 watts continuous is actually very interesting. They basically say you can't deviate more than, I think it's like 2 degrees C in any certain time period. And so you can actually write software to get around that, where your motor might cool off a little bit more than 2 and heat up a little bit more than 2. And so you can be like, oh, well, it's just 250 watts continuous, even though the motor can do 1,000 watts or whatever.
Is that just a European regulation at this point?
The rules are different in the EU and the US. I think US has always been 750, but it's also different in some states, and I honestly don't have that off the top of my head.
Yeah, fair. But you're basically constrained by regulation to stay at 750, and you're like, okay, how can we optimize based on what we can do, and that's torque. So that's how you got to 150. Okay.
Exactly. Yep. And it's important to note that torque is really what drives the size of a motor, and torque is what feels good when you're accelerating. So optimizing for torque density is the correct thing to do. You don't want to optimize for power density because you can make a fast spinning motor with low torque, loud, etc. But the right thing to do is optimize for torque density in a small package that's quiet.
Awesome. And that's the goal here with Accelerate.
Yeah.
Awesome. So with all these new products in mind, I wanted to ask you, how does the OEM conversation come in? Because when you're building a mid-drive motor, there's a lot of collaboration. You need to get these motors into bikes at the point of inception. Have you started those conversations? Are you collaborating with anyone? And how do you see yourself competing with the Bosch, Shimano, all these motor systems that are just, so ingrained in the market?
Yeah. So that's actually how that motor was born, funny enough. So we were pitching Elevate to tens, I want to say almost 100 bike companies, but we'll call it high tens. And pretty much unanimously, this was like 2021, 2022, folks said like, hey, we want something integrated in the bike, cool idea. And so we kept pitching this, and one company in particular really liked our engineering team, and they said, hey, can you build a motor that's integrated? And so that's what led to Accelerate the mid-drive, basically starting that development. So fast forward to today, the bike market's had some bumps. And so the mid-drive product has slowed down. The development path on that has slowed down. But there's actually some light. We're talking to a couple other outlets now that are significantly larger that might be interested in licensing the tech. And so we think there's probably new life with that, which may be more of a technology license, or some sort of partnership where we're doing the production in collaboration with someone larger.
Okay. So it sounds like the appetite could be for some companies to make their own bespoke system and license that technology then.
Yeah.
That's interesting, because you can tell there's clearly a disconnect between a lot of these brands and the motor manufacturers. So I could see them wanting to work that together. And another thing is, I think technology will drive the desire of these brands. You've seen with this DJI motor. Obviously, DJI is a huge company, but there was no incentive to move away from Bosch and anything until there's this awesome new tech that has all this power and this lightweight package. So I think if you're able to push the limits of the tech, you can absolutely break into that landscape.
Yeah, 100%. And I would say that's also how we're going to break in with this motor, with Elevate. I think it's just offering something that you can't get in any other solution, and that's why we're trying to position ourselves as a tech company and really focus on key metrics.
Totally. Okay. Very cool.
Maybe just one more thought on the kind of OEM interest. So we're now actually getting some interest from a couple OEMs on this motor, on the aftermarket motor. And it might be initial collaboration of, hey, this is approved to use on our bikes. So that's kind of step one. And we have a couple companies we're talking to who are kind of verbally already have given the thumbs up. And then step two would be, find more of the bespoke brands who either don't have an e-bike offering or are more biased towards the analog side of things. And basically this motor, Elevate, with pedal assist will be maybe a solution to actually let them keep their analog bike offerings for longer.
Right, and just add on. Very cool.
Exactly.
Do you think that could also materialize as better integration? So maybe internal cable routing or a more fitting bracket to mount the motor? How do you see that coming together?
Yeah, I think there could be maybe some dedicated mount points for the harness. Really, we're going to get down to a single wire where it's just the motor to where the bottle cage is, and the pedal assist is all done wirelessly. So there could be some integration there. Could be just kind of the system is pre-assembled on the bike as it ships, and so people can just opt to have this bike ready for Elevate. But I think the motor itself might be almost a way to, I don't want to say save analog bikes, but like kind of give them more life, where you see more and more of the attention is on e-bikes.
Yeah.
But if this lets you have both, going back to more traditional analog bikes may actually become more compelling in certain situations. So in a way, an e-bike motor could save analog bikes in my mind.
Yeah. I think also with the way the industry is going, people need to save money. And this could be a way to have both without spending on two bikes. And that's maybe born out of the need. So I think the product is in a really interesting spot.
Yeah. Yeah.
So one, maybe I should tee the whole thing back up again. Maybe you could just say, so that brought me to the point where I wanted to build this off of.
Yeah. Can we get the goodie bucket? Cause I think there's a good story in here. You have, sorry.
We good?
I'm just resetting the cameras. We're going to turn off soon.
You want to hit the light too, just in case?
Yep.
On off.